Hello friends, welcome you all in this session. In previous session we were discussing how to crash a network using free float method, and we were solving this particular question. And so far we have reduced the duration of this project up to 13 days. However, its initial duration was 20 days, right? So let us again move further. There are two critical paths. You have got 1, 2, 1, 3. Let me put it in this way: 1, 2, 4, 5, 6. First critical path, 1, 3, 5, and 6. Second critical path. So we have written these two critical paths here as 1, 2, 4, 5, 6, 1, 3, 5, 6, and slopes of course you can easily write by looking at the very first table, right, for this path also, right. And crash limits for 5, 6 we have exhausted crash limit, and for 3, 5. So let me put it in this way, right. So for 1, 2 we cannot reduce it further, 5, 6 we cannot reduce it further, right, and 3, 5, right, we cannot reduce this activity further, right. Now we have to take a decision here. What decision we have to take? We have to decide which activities from these two critical paths should be selected for compression. So if you look at this activity 2, 4, its crash limit is 1, and from here you have got only this activity left, 1, 3, isn't it? So crash limit here is 1, crash limit is 3. So there is no need of going for test step. You just reduce duration of activity 2, 4 by 1 day, right. Had it been 2, we would have gone for test step, right. So let us reduce duration of this project by 1 day. So this So this 1, 2, 3, 4, 5, 6. So this is 2, 6, 2, 4, right? We have to reduce 2, 4. So this is 2, 4. This is now 2. This is 7. This is 3. This is 4. This is 4, right. 4 star, right. You cannot crash this further, right. Similarly for activity 3, 5 also. Now 1, 2, 3, 4, 5, 6, right. Okay. Just check whether we have reduced it by 1 day or not. Yes. So 2, 6, 7, 2, 3, 6, 4. Yeah, this is missing, right. So this is 6. Right, and the directions are like this. Now look at all T's and TL. T at this point is 2. In fact, let me draw a line here, because these critical path, slope and CLs are for this network, right, not for this network. Okay, so T is equal to 0, T is equal to 2, T is equal to 6, T is equal to 4, right. It's 2 plus 2, 4, and 4 plus 4, 8, and 6 plus 3 is 9. So T is 9 here, and this should be now 12. So why this is coming 13? Okay, in fact, yes, we didn't reduce 1, 3 by also 1 day. So 1, 3 is where? 1 3 is this, yes, because we decided to reduce 2 4 and 1 3. So this is also this would also be reduced, so this would be 5, right? Okay, so this is 5, this 0 plus 5 5, this is 8, right? 8 plus 4 is equal to 12, right? It is common sense. Since this total duration is 13, we are reducing 2 activities simultaneously by 1 day, so this has to be 12, right? So if if you are not getting 12, it means you have made some mistake in drawing network, right? So this is 12, right? Now let us look at TL. TL here is 12, TL here is 8, TL here is 4, TL here is 5, right? TL here is 2, TL here is 0, right? Critical paths are, you got 2 critical paths, 1 2, 2 4, 4 5, 4 6 and 1 3 5 and 6, right? Let us also calculate free float limits. So this 12 minus 2, this 10, and 10 minus 7, it is 3, right? So free float is 3, and free float for this would be what? It is 12 minus 4, 8, 8 minus 6 is 2, right? So 3 and 2 are free floats of non-critical activities, right? Let us move on to next step. So which paths are critical paths here? You got 2 critical paths, 1 2 4 5 6 and 1 3 5 6, right? So in fact, let me not write slope and crash limits for these two, because we have done this, we are done with this, because now crash limit is 0 here. So you have got only for 4 5 this is 40 and crash limit is 2. For 5 6 this is 0, right? You can't do for 5 6 also. And in this path this would be now 30 and crash limit is 2. This is 20 30. Of course these are also gone, right? 3 5 and 5 6 are also gone, right? So you are left with 4 5 and 1 3. 4 5 and 1 3. Is it necessary to go for test step here? Should we go for test step? We should not. No, we should go for test step, because these crash limits are more than 1, right? Since these crash limits are more than 1, we will have to go for crash limit. Test step. And test step we are doing in this part of the board, right? So test step 3. So what is test step? Reduce duration of activity 4 5 and 1 3 by 1 day, right? And see what is the effect of on these reduction on free floats of non-critical activities, right? So let us go for test step. So what we will do, we will reduce 4 5 by 1 day and 1 3, right? 1 3 by 1 day, right? Okay, so let us draw a network here. So 1 2 3 4 5 and 6, right? All these are the directions. So we have got 1 2 is now fixed, right? 3 5 is also fixed, right? 5 6 also fixed, right? And 1 3 is 5 here. Now we have to reduce it to 4, right? We are doing test step, right? So when we reduce this activity by one day, we will see how these non-critical activities floats change, right? So this is 1 3, where is 4 5, 4 5 is this, right? So this is now 3, right? This is 3, all other values will remain same, 7 2 6, right? Now calculate T and TLs, right? So T here is 0, T here is, this is, right? So T here is 2, T here is 4, T here is 4, right? So this is 7, this is also 7, this is also 11, right? And TL here is 11, TL here is 7, TL at this point is 4, right? 7 minus 3 is 4, TL here is yeah, this is 11, 11, no, we will take this path. So 4 minus 2 is 2, TL is 0. And which were the non-critical activities? These two, right? 2 6 and 4 6, right? Let's calculate their floats now. So 11 minus 2 is 9, 9 minus 7 is 2. So there is no change in, yeah, there is a change in free float of this, right? Earlier it was 3. What about free float of this? 11 minus 4, 7, 7 minus 6 is 1, yeah, this also got changed. So earlier 3 and 2, now 2 and 1. So what is free float limit? So free float limit is minimum of these two, right? Minimum of 2 and 3, right? Which is 2. And crash limit is, what is crash limit? Is also 2. So compression limit is minimum of free float limit and crash limit. So minimum of 2 and 2 is 2, right? So we can compress activity 1 3 and 4 5 by 2 days, right? We can compress activity 1 3 and 4 5 by 2 days. So what decision we have to take? We have taken, what decision we have taken? We have decided to compress activity 1 3 and 4 5 by 2 days, right? So this is our final decision, right? Let us look at this network now. One, two, 1 2 3 4 5 and 6. This is our network, and these are the directions, right? And now we will write time durations for all these activities. So this 2 is fixed, 3 is fixed, 4 is fixed, right? And now since we are doing it for activity 1 3 and 4 5, 1 3, where is 1 3? 1 3 is this. We have to reduce it by 3 days. So this is now 2 days. We have to reduce this by 2 days. So this is now 3, and which is also now fixed, right? You cannot reduce it further. The other one is 4 5. Where is 4 5? 4 5 is this 2. Now this also is exhausted, right? What is left? Of course this is 2. So this is 7 and this is 6, right? Let us calculate T and TL values. 0, T is equal to 2, T is equal to 3, T is equal to 5, T is equal to 6, right? 6, 4, this is 10, right? And T here is 4, not 5, right? This 2 plus 2, this 4, right? So 4 plus 2, 6, yeah. So from here also we will have critical path, right? So TL is equal to 10, TL is equal to 6, TL is equal to 3, TL is equal to 4 and TL is equal to 2 here. Similarly TL is equal to 0 here. Again you have got 2 critical paths. In fact this also is exhausted, right? 2 4 is also exhausted. So the critical paths will remain same. So you have got 1 2 4 5 and 6, 1 3 5 and 6, right? Now let us try, can we further reduce this network? So for this just write critical paths here. Critical paths are 1 2 4 5 and 6 and 1 3 5 and 6, right? Since you have got 2 critical paths and for which is there any yeah, for 4 5, for 4 5, right? You have got 4 5. No, since you know these two are critical paths, right? And on all these critical paths you have exhausted all crash limits. So further crashing is not possible. Further crashing is not possible. Why? Because you have exhausted all these crash limits, right? As far as these two activities are concerned, you cannot reduce duration of the project by reducing duration of non-critical activity. So with this we complete this question, but let us find out what is the final solution. We have done so much of calculations. Let us find out what is the exact answer to this question. So let us find out total cost. So for this question, the total cost is, in fact we have done several iterations. Initially you had 20 days was the answer. Then at that time direct cost was, it's 1980, right? It's given in this table, right? So 1980. Indirect cost was 800. Why 800? Because indirect cost is 40 rupees per day. So this is 800, right? For after that your solution was 18 days, then it was 15 days, 14 days, 13 days, 11 days, and this is 10 days, right? Last solution. So direct cost, of course, as I said, direct cost will increase. So 2020 you have got 2110, 2150, 2210, 2350 and 2420, right. Direct costs of course 720, 900, no, yeah, this 720, right. 600 is 15 into 40, right. 560, it's 520, 540, then 440, 400. Just check this once again. So 800, 720, 600, 560, 520, 440 and the total cost is this. So you have got total cost as 2780, just add these two value, 2740, right, 2710, 2710, then you have got 2710. For 15th day it is 270, for 14th day also 2710, for 13th day 2730, 2790 and 2820. Now if you look at the total cost curve carefully, total cost curve is decreasing, right. Here to here it has decreased, it's decreased. Now at these two levels it is constant, right, and then it is started increasing. So what is final solution? What is the final answer? You should the optimum cost is 2710 and optimum duration is 14 days, right. If you further crash it, then your cost will increase and it will continue to increase, right, because your direct cost is increasing, your direct cost is increasing until this point. In other words, your the decrease in indirect cost is more here up to this point then direct cost, and after this point things will change, right. The direct cost will increase more and indirect cost will decrease less. So the optimum solution is 14. So with this, let me summarize what we did in this session. In this session, in fact in last 3 sessions we did this question, and we applied free float method. Free float actually acts as a guard against creation of a critical path. So that's why we always check whenever your crash limits are more than 1 for development of critical path using free float. So with this, let me complete here. Thank you very much.